Okay, for the first part of this video, we're going to go over this problem from the homework set. Quite a few people asked questions on it, and most of the questions are about using the correct domain, so we're going to go over those. So let's do the first part of the problem, which is find f of g of x. So to find f of g of x, we need to put g of x into f. So plugging that in, we get 3 times 8x squared minus 5 minus 2. Let's do a little bit of simplifying here. That's going to be 24x squared minus 15 minus 6. Oh, whoops, nope, not minus 6, minus 2. Got a little carried away there doing my distributing, didn't I? Minus 2, and that becomes 24x squared minus 17. So there's our function f of g, and what we need to do now is we need to figure out its domain. Well, we know that it has a square root sign, so we know that we need to make sure that everything under the square root sign is greater than or equal to 0 because we can't take the square root of a negative number. So we need to find where 24x squared minus 17 is greater than or equal to 0. So to do that, we need to solve this quadratic inequality. So to solve the quadratic inequality, the first thing you need to do is you need to find the zeros. And to find the zeros, we set 24x squared minus 17 equal to 0. So we get 24x squared equals 17 using the square root method. Divide by 24. We get x squared equals 17 over 24. Square root of both sides. We get x equals plus or minus the square root of 17 over 24. Now this just tells us where our quadratic equation here, this guy, equals 0. So remember when you graph quadratic equations, this might be a handy time to grab your graphing calculator and graph 24x squared minus 17. It's going to look something like this when you graph it. Now this isn't a perfect picture, but you get the idea. And these two zeros right here, we found are plus square root of 17 over 24 and minus the square root of 17 over 24. So we want to know where this function, 24x squared minus 17, is greater than or equal to 0. Well, I'm just going to switch the color of my pen. Oh, there we go. That happens exactly from here on this way, and from this point on down, right? Between these 2 points, it's less than 0, and to the left and to the right, it's greater than or equal to 0. So the answer for the domain is from minus infinity up to minus the square root of 17 over 24, inclusive, union the square root of 17 over 24, up to positive infinity. And that is your answer. Here is your function, f of g up here. And here is its domain right here. Right, so that was the first part. The second part wanted us to find, they wanted us to find g of f. So we're going to try and do that one too. Let's go ahead. Now if we want to find g of f of x, that means we need to find g of, and let's remember what f of x was here at the top, root 3x minus 2. And so we're going to plug that into g, which was 24x squared minus 17. So we're going to get equals 24. Now we have this business, 3x minus 2 squared minus 17 as our g of f of x function. So we can simplify that and we get 24. The square root of a square is more or less 3x minus 2 minus 17. So that's equal to 24 times 3 is 72x minus 48 minus 17, which is equal to 72x minus, let's see, what's 48 minus 17 minus 65. So there's your function g of f. But what is its domain? Well, that's a little bit harder question than you might initially think, because if you look just at this guy, then you say, oh, it's just a linear function and its domain's all real numbers, but it doesn't really work like that, because what happened was this is really a composite function, and every x first has to go through 3x minus 2, then it gets its square root taken, then it gets squared, then multiplied by 24, and then subtracted from 17. Now, if your x is in the domain, it'll all just work out simplified down as 72x minus 65. But whether you see it or not, you're really still going through that process. So really, you have to make sure, can every x go through this piece right here? And if it can, then you know that you need 3x minus 2 to be greater than or equal to 0, so you can go ahead and take that square root. So that means you need 3x greater than or equal to 2, or x greater than or equal to 3 halves. And that is your domain. 3 halves to infinity.